This is your boy Maingo offering a free will show of massive quality mathematics. Support me by pressing subscription button. Let's go. Hello guys, today I'll be teaching you how to solve homogeneous differential equations. I'll be providing you with techniques to solve homogeneous differential equations with constant coefficients. So without wasting any time, let's get into it. Number A, y minus 4. Since you can see that we've given a third order differential equation, what you have to find first is an auxiliary equation. We find an auxiliary equation we will find it by replacing derivatives with m. If it is a third order derivative, then our auxiliary equation would be m cube minus 4 m square minus 5m equals to 0. So in other words, you replace derivatives by m. So it is m cubed because it's a third order derivative, and minus 4m squared because it's a second order derivative, and minus 5m because it's a first order derivative equals to 0. So you have to find the roots by factorizing this. I will take out the common factor m. This will be m square minus 4m minus 5 equals to 0. So since you understand that if two factors are multiplying each other equals 0, we take either one factor equal 0 or the other factor equal 0. So this one, we can continue factorizing this trinomial equation. This would be m. The factors of m is m and m. So the factors of 5 is 5 and 1. So here it is minus 4. If the middle term is negative, so the bigger number takes the negative side, which is minus plus equals to 0. You can test whether this, when you expand this, you get this expression. So this would be m plus 1 equals 0, or m minus 5 equal 0. M is equal minus 1 or m is equal 5. You can see that you have your roots now. M equals 0, m equal minus 1, and m equal 5. These roots, you can compare them. These roots are real and distinct. The word distinct just means different. These roots are real and different. So the particular solution, or the general solution that we want, is of the form y of x equals to c1 times e to the power of m1x plus c2 times e to the power of m2x plus c3 e to the power of m3x. So where there's m1, you're going to put 0. This is m1, m2, let's put m2, m3. We're giving them names. m1 is 0, m2 is 5, and m3 is minus 1. So we'll substitute them here into our general solution form. This is c1 times e to the power of m1, we put 0 times x plus c2 times e, m2 we put 5x plus c3 times e to the power m3 we put minus 1, which will be minus x. So therefore the general equation will be c1, because any number to the power 0 is 1, c1 plus c2 times e to the power of 5x plus c3 times e to the power of minus x. This is a general equation for this particular problem. So you can be given an initial conditions where you can substitute this. You can just find this arbitrary constant. In this case, we are not in those kind of examples. So let's just move on to number B. Let's move on to number B. B is y plus 8y plus 16 plus 8y prime plus 16y equals to 0. So this one, we have to find the auxiliary equation as normal. And we replace the derivatives by m. This is m squared plus 8m plus 16 equals to 0. Why is it a constant? Because there's no derivative here. That's why we're writing 16 only. So we will factorize this. This is the m plus, what are the factors of m is m and m. The factors of positive, positive, and positive. The factors of 8 is that will multiply each other, give us 16, and when we add them to give us 8 is 4 and 4. This is equals to 0. That means m plus 4 is 0, or m plus 4 is 0. M equal to minus 4, or m equal to minus 4. You can see that therefore m is just minus 4 and it's just twice. There are two m equal minus 4. So the general equation, or the form of the general equation that we seek, is y equals c1 times e to the power m x plus c2 times x times e to the power of mx. Because it is twice, so we introduce what is called x. So this one is slightly different from the previous one, but because they are real, the roots are real and equal, so we introduce what we call x. So if the roots are triple, then you say plus c3 times x squared times e to the power of mx. In this case, we would not have triple solutions. So now this one will be y of x equal, where there's m, we're going to put minus 4. This is e to the power minus 4x plus c2 times x times e to the power of minus 4x. This is the general solution of that. So you can see that this is very simple. It's very simple problems. So we can move on to number C. If you're following, as I was running out of space, so I decided to erase everything so that I can take number C very well. So number C is 9y fifth order minus 6y fourth order plus y third order. So as usual, we'll find the auxiliary equation. So is the method of replacing the derivatives with m. This is 9m to the power 5 because it's the fifth order, minus 6m to the power 4 because it's the fifth order, plus m to the power 3 because it's the third order, equals to 0. So I will solve this by factorization method to find the roots. I will take out the common factor of m cubed since it's the lowest common factor. This will be 9m square minus 6m plus 1 equals to 0. M cubed equals to 0, or 9m squared minus 6m plus 1 equals to 0. M equals to 0, or I can factorize this. The factors of this is 3m and 3m. The factors of 1 is 1 and 1. Because it's plus here, it will be minus and minus. So this is equals to 0. You can see that 3m minus 1 equals to 0, or 3m minus 1 equals to 0. M will be 1 over 3, or m will be 1 over 3. Therefore, m equal 1 over 3. You can see that it is twice. That means we have the real and distinct roots, but this other one is twice. So the general solution that we said is y equal to c1 times e to the power m1x plus c2 times e to the power of m2x plus c3 times x times e to the power of m2x. Since you can see that we have m1, m2, then m2 are twice, are 2. That's why we're introducing this. So this will be y equals to c1, where there's m, we're going to put 0, 0 into x plus c2 times e 1 over 3x plus c3 times x times e 1 over 3x. This will be equals to c1, any number to the power of 0 is 1, c1 times 1 is c1, plus c2 times e to the power of 1 over 3x plus c3 times x times e to the power of 1 over 3x. So thus this is the general solution of that differential equation. So guys, I hope this video is suitable for you to learn very well. So if you find this interesting and beneficial, so support me by subscribing, sharing, and liking my videos. Thank you for your attention.